Welcome to my presentation of 3D printed liquid-cooled heat sinks for power electronics applications. My name is Rocneanu and I am the VP of Business Development for IQ Evolution. Before we start, I would like to thank Bodo and Holger for setting this event up and inviting me to present. Let's start with a short overview of where IQ Evolution is coming from. IQ has been founded in 2006 and started with nickel-based coolers for the high-power laser diode market. Over the years, they filed some patents for 3D printed monolithic coolers and in 2017 made the strategic decision to move into power electronics. In 2020, Foxy Power became the strategic partner for business development and sales. In general, IQ Evolution has the following target applications: automotive, aviation, energy storage, solar and DC fast charger. One development has been for the automotive industry the modification of the flow rate and pressure drop. While in the beginning we started with coolers with a high pressure drop, in the meanwhile we have coolers with a flow rate of 6.6 liters per minute at 100 millibar. Let's come to the manufacturing process. The process is based on selective laser melting, where we only require a laser machine, form and cut file. The stainless steel powder is deposited on the form. The laser beam comes and melts the powder layer for layer. After the cooler is created, the remaining powder will be flushed out and reused. We often hear the questions, can you do this with aluminum or copper? And the answer is, we focus on stainless steel because the wall thicknesses we can reach are only 150 micrometers, while with copper and alu you would have at least 800 micrometers and need different laser machines and more machining time, making the whole process more expensive. We also have a high degree of flexibility and customization, even though we don't need any tools. The idea of this technology is to just build the structures you need and to cool the hot spots. So it requires a new thinking from spreading all hot components over the PCB to bringing them back together and best on one cooler. The smaller the cooler, the less machining time and the less costly the cooler will be. Many people think 3D printing is just for prototypes and quite expensive. However, IQ has set up the process from the beginning to be mass production capable. What you see here is a digital twin of a semi-automation, for example, for the IQ Twin. We will start to automate from 100 kilo pieces per month, and we can scale up to 25 million parts per year before we start to fully automate the whole process. This part will be in the high volume in roughly 7 to 8 euro range. I often get asked about a standard product portfolio. If you will, we have various coolers which are built for industrial standard discrete and module packages, such as TO247, Flow E, and 62 millimeters. You can see that we can cool from 240 watts per side to 750 watts for the Flow E to even 1500 watts per side for the 62 millimeters. And we expect an RTH of 0.07 to 0.08 Kelvin per watts. I mentioned in the beginning the evolution on the flow rate and pressure drop. When we started in 2020, we had rather a high pressure drop and lower flow rate. You can see with the IQ Twin Industrial, it has about 400 milliliter per minute at about 100 millibar. The automotive industry requires about 100 to 200 millibar at 8 to 12 liter per minute. And thus we came up with the Twin Automotive version, where you already get 1 liter per minute at 100 millibar. You can also see the different outlets and inlets on the coolers. On the performance side, you can see that we initially received 7 degree lower surface temperature for the same pressure drop. We further modified the pressure drop and flow rate, as can be seen on the next page. You see here the flow rate and pressure drop for the IQ Big V10 versus the IQ Big 53. What you can see is that we further improved the flow rate, and now the V10 has about 6.6 liters per minute at 100 millibar. But we can basically adjust the pressure drop and flow rate to be anywhere in between those two curves. What you can see here on the left is a big IQ 53 industrial, which has been evaluated with a temperature of 25 degrees and at 100 millibar and 2.3 liters per minute. For isolation, and Bergquist high flow 300P has been used, and we were able to dissipate 750 watts per side. Unfortunately, the pump wasn't strong enough to evaluate further. On the right side, you see the IQ Big V10, which has 2.3 liters per minute already at 20 millibar. Here the total dissipation was 3 kilowatts. As you can see, we cooperate with various module manufacturers and hopefully have some further evaluation results by until end of the year. Besides insulating foil, you can also use different attachment methods like soldering, silver or copper sintering. One example of this is being shown here. You see this package is being used by Tesla and has been silver and copper sintered to an IQ Twin with a nickel and gold metallization. The pressure used was about 25 megapascal, and one reason we will ask you after the dimensions of the coolers and die location is that we want to make sure that the coolers are built for pressure sintering. Now let's get into some real applications. Here, the ICEA Institute of RWTH Aachen was challenged to build a 210 kilowatt DC-DC converter for a truck. The converter had to fit into a beer box. Initially, the approach was to use silicon standard modules and conventional cold plates. But unfortunately, it didn't fit into the given space. Then they changed to IQ Evolution coolers, which enabled them to use smaller modules, and less heatsinks, as well as switch to silicon carbide. These changes led to a reduction of 97% weight, an increase in power, and a fitting converter. What you see here is a 350 kilowatt test stand for an inductor from one of our customers. They have run it at 1000 and 1200 amps with a conventional cooler and our solution. For both evaluations, they have used silicon carbide devices in the same module, hence it's a very good apple-to-apple comparison. What you can see is that with the conventional cold plate, the temperature varies from roughly 50 to 95 degrees, and a lot of damping is required. When you look at the IQ Evolution solution, we have a temperature of 45 degrees, a maximum temperature of 45 degrees C, and the spread is much smaller, maybe around 15 degrees C. Also, the overall damping is reduced. In the coming months, we will describe this project in more details in Bodo's Power, so watch the next magazines closely. And finally, as a summary, we use stainless steel as a material for our 3D printed liquid coolers. Since the coolers use turbulences as a heat transfer, the thermal conductivity doesn't matter. We have printed microcoolers for discrete semiconductors, for example the IQ Twin. The twin in high volume will be manufactured every 90 seconds and has a heat flux density of more than 240 watts per square centimeter with 50-50 water-glycol mix. The coolers can be used from both sides and the channels are independent from each other. We can also print modules, coolers for modules, either for up to 6 packages per side or only 2 to form a half bridge. It depends what the customer needs. The coolers are corrosion free and can be used in serial or parallel connection. Hence, we can get to any flow rate or pressure drop you would like to have. Due to the 3D printing, we are also flexible in form and shape, and custom-made geometries are not an issue. Finally, we can also print very thin coolers which we could embed into the PCB and connect via O-rings. Thank you very much for your attention. If you have any questions, please contact us.